So there's a reason that we have to use multivariate analysis. All right. Okay, people are keep coming. Okay, and it is important for you to have this skill. Okay, so last week we have discussed about, and I asked you to watch the response phase methodology, right? RSM, which is very important, especially for us, because we study a lot of factors, a lot of variables, independent variables over dependent variables. So very important for us researchers to get to use or to get to know all this skill set. Yeah, it's no longer practical if we are to use just a graph to plot one factor over one factor and move to another optimization after one another. It's not really practical because now we have the mean, we have the software, we have the system, the multivariate analysis to be used to do the optimization by using multiple variables at one time. So please do equip yourself with this kind of analysis. Okay, this is, I'm giving an example of how the multivariate analysis being used, okay? Right, so this is related to our research on Ganoderma issue in palm oil. So that Ganoderma cause the basal stem rot disease. Okay, so this is how it looks. The extreme one where the fruiting bodies appear. And once the fruiting bodies appear, the tree is no longer can be saved, right? So this one also is the symptom where the what we call as the front leaf, okay, droop down folia. It is drooping. Okay, so this is okay the issue of basal stem rot, and it is considered as zombie apocalypse in oil palm industry because once it is infecting that plantation, the mean of infection is through soil, so it will also affecting other trees, and it results in a lot of loss. Okay, so I'm just giving you an introduction on this. So how uh so my students has just finished a viva, tried to relate a biomarker for early detection because somehow there is a detection for this Ganoderma, but it has to be by sampling and then bringing back to the lab. It is PCR based. It is also immuno related where they detect certain peptides, certain protein. So that is something what we call as destructive as well as time consuming because everything has to be brought back to the lab. So in this project, we have what we call as trying to detect what are the important VOCs as well as metabolite that indicate that the young tree or the tree has been infected by this fungus, okay, who actually have infected, but there is no symptom. Okay, it affect, but there is no symptom. Okay, so if you look at here just now, okay, you can see the what we call as the fruiting bodies. Yeah, okay, the fruiting bodies. So if it is at this stage, then the drooping folia, then it is no longer can be salvaged or can be saved. Okay, so our intention is to detect if there is VOCs or metabolites, secondary metabolites that can be detected, which indicate it becomes as a marker for early detection. So when we started to do this, okay, the problem, of course, I mean, we are using what we call as eNOS to avoid destructive. So we want to have non-destructive. Okay, so by sniffing the VOCs, the metabolites from the leaves. Okay, because we do not want to poke the tree to sample and then bring it to the lab. Okay, because that will sort of injure the tree, which is they don't want it to be happen. So what happened here is we have a lot of data. We have a lot of data because we are working with living things. And you can imagine that they have a variation of data. So if you look at here, all right, I just want to show how the PCA, one of the multivariate principal component analysis, can be used to help when you are dealing with a lot of data, one, and the other one is you are working with a lot of variables, because if you are working with living things, okay, you are prone to variety of trees, okay, and then you are prone to geographical area. So sometimes it really actually uh, uh, affect the volatile, the metabolite that is being released by the trees. So how do we manage the data? Okay, so in order to manage the data, we have to use a system. Okay, so this is the data that taken from the eNOS. Okay, let's move on towards the results. So you can see here, there's a lot of confirmation that has to be done. Okay, the infection is like cancer. They are stage 1, 2, 3, and 4. So in order for us to claim that we have done for early detection, then we have to work our way through the T1 and T2. Okay, so let me show towards the end. Okay, so you can imagine this is from the GCMS data, and then we also validate the reading, which is used, okay, the GCMS is used to validate the reading from the eNOS. Okay, so I'm not going to be able to explain the data, the results from here, but with the help of this PCA, okay, PCA is different than PLSDA. BLSDA is called supervised. Okay, I hope that you have watched the video, so you might understand some fundamental of the PCA. Okay, you can see that from the eNOS data, which is validated by using GCMS data, you can see that there is some pattern. Okay, there is some pattern. Not to say very significant difference, but there are certain percentage of separation, a certain percentage of pattern segregation between infected and healthy. Okay, so the data at this moment has to be analyzed, okay, by the help of this multivariate analysis, in this case using PCA, to give us an indication whether the tree is healthy or is infected. Okay, so the one that we the one that we have done is all in standard condition, means that it has been infected in standard condition. It's not really at the real plantation or real nursery. It is under control condition. Okay, so you can see that there's a lot of processes that you can do, and you can do pattern recognition. Okay, so this is very important. Okay, tools for you to use. Okay, if not, then we are working with a lot of data, then how are you going to solve that data? Are you going to plot it with Excel, or how do you make sense of the data? Because there's so much, okay, there's so much data. You can see the one that generated from the eNotes is like this. So, and then you have so many categories to come up with. So you need to save the data into a software that can analyze and give some indication whether you can segregate, okay, the the conclusion that you are able to separate the category between infected and healthy. So I'm just giving an idea how PCA can be used. It's very important. Okay. So I don't know, any of you, has everybody watched that video? Please do watch if you haven't, if you have not done that. Okay. So stop share this one. So the one that I would like to discuss today is about IP. Okay. Okay. Make sure that when you enter this Zoom, okay, you need to have a proper profile name. If not, then I will not admit you into the class, because I'm not sure who is actually trying to join the class. So please make sure that you put a proper profile name. Yeah. Right. Okay. So this is about innovation. Okay. And we actually, not to say that you're going to do it, but it is actually very important for you to at least know at one stage you need to probably protect your innovation. Okay, so you're probably thinking about, oh no, I'm not going to write, my research is not going to be that level or not. No, it does not have to be. You need to have a product, you need to have a very complicated science. No, when you are protecting your innovation, it can be as simple as a recipe, okay, a secret recipe, or it can be just as simple as your trademark. Okay, right. So very important for you to at least get to know the protection of your innovation, the ownership of the innovation at the beginning of your research. Okay, why you need to know this? Because in the end, if there is a dispute between you, your supervisor, and UPM, at least you know one or two things of your right. Okay. Now, this is particularly for UPM, yeah, because you are students of UPM, so you have to know that all IPs get handled by Putra Science Park office. Okay. So anything related to filing of IP, IP stands for intellectual property, is handled through this office, as well as for the transfer of the technology. For example, once you finish your master's, and then you come out with a formulation, for example, formulation, regardless if it is pharmaceutical or if it is cosmetics, and it is working, you think that it is working, then you have to discuss with your supervisor, because you cannot just okay, bring the formulation outside and then you commercialize it. You cannot do that, because you have to understand that you, the supervisor, and you can be the innovator, but the ownership of the IP, regardless patent, trade secret, trademark, or whatever, is owned by UPM. You have to understand that. Okay. And if you is found using the innovation owned by UPM, okay, you can be yeah, UPM can sue you. That's the thing. And if it is evidence that the research is done in UPM's lab under the supervision of the supervisor with the knowledge, because the supervisor's salary is being paid by the university, so all her time during supervision as an employee of UPM. So this is why whatever innovations that is supervised under him or her is owned by UPM. So you have to understand that you cannot just bring the formulation outside and probably talking to industry partner and start cooking something, okay? Because the ownership is UPM, okay? All right. So these are things that the evolution of the innovation Putra Science Park office. Okay, so just skip this. All right. Yeah, so Putra Science Park also handle all the negotiations between university, whatever innovation that is interested to be shared with industry and community. So this is done through Putra Science Park. Okay, so you can browse the website as well as what are the active patent from the website as well. Of course, because University Putra Malaysia, okay, Putra stands for Pertanian for untuk Rakyat. Okay, so you can see there's a lot of examples which is more towards agriculture, vaccine, fertilizers, green pesticides. Okay, so this one is fish feed, right? As well as there is this is quite famous. Okay, for those who have skin issues. Okay, so this is from food faculty. All right, and there are a series of discussion, a series of processes that has to be undergone before certain technology or certain innovation to be commercialized. So it's not that easy. Some terms has to be finalized between the innovator, which is probably you and your supervisor, and PSP, Putra Science Park, also the third party which interested with your formulation, for example. Okay, so these are the summary of the process. Okay, so when you have IP, intellectual property, it can be licensed. Okay, so license is not what we call as uh, the third party or the industry or whichever entity that interested with your innovation, they can have an option to license. License means that they possibly be interested in 2 or 3 years only to work with your innovation, and after that probably they can just, let's say, no more, thank you, whatever. Okay. The other way around is buying the IP in one go, meaning what we call as outright. Outright means that we the the interested party will just buy the ownership from UPM. It's not license. License is time based. There is 2 or 3 years involving that. Okay, so the process is actually quite lengthy. Okay. All right, this is just the achievement from Putra Science Park, but this one is outdated. There's of course, a new one. Okay, so let us get to know what are the IPs, okay, that you can apply. Okay. this is just a guideline, okay? We have patent, we have industrial design, trademark, copyright. Okay, so this basically, when we talk about research innovation, okay, invention, usually we talk about patent. It can also be what we call as trade secret, okay? So there is one called, it is not in here, but trade secret is about secrecy. For example, if you have recipe, food cooking recipe, or even the formulation can also be a trade secret. So TS is also one of the most used protection, okay? But most of us usually target patent, okay? So the inventions, the research innovation that you have, usually we are targeting patent. But depends if you work with like architecture related, engineering, design, then probably it falls under industrial design. And trademark usually name, logos, brand, okay, those are trademark. Whereas copyright usually is artistic, like songs, musics that you wrote. Okay, so it is copyright. Okay, in Malaysia, if it is filed for under Malaysia, all those verification is done by what we call as MyPo. Okay, so MyPo will decide whether the patent or the IP is good to go, whether it is it's not somebody else patent, somebody else invention. They will screen through all the documents that the innovator submitted. Okay, let's look at patent. Right, meaning of invention. An invention means an idea of an inventor which permits in practice the solution to specific problem in field of technology. It's very technical term, but what you actually can patent sometimes is product, okay? But it can also be a process. It does not have to be a tangible product when you apply for patent, because sometimes it requires more than one. It might be one, two, or three, or four. That's four patents that can is making you it, that helps you to come up with a product. Okay, it doesn't have to be with a single patent. You can have a ready product. Okay, you might need more than one, or might add up a few patents to come up with the final ready product. Okay, so that's why you can patent the process. Okay, and the second patent is based on the first patent. Okay, the first patent is called foreground IP. So you can also use your first IP to build or to expand to the second patent. Okay, right. Of course, when the authoritative body like MyPo, what do they look for the evaluation criteria? Of course, it's the novelty. We talk about the novelty where you start with your work, okay? So when you talk about your novelty, it does not have to be, again, a product. It can be also an inventive step, okay? Okay, new improved version, for example, but at least there is something new which is inventive, okay, towards that, whether the procedures, the formulation, you have a new inventive step. It's not 100% new, but there is some inventive step, okay? All right, new material, for example, new use, okay? So it doesn't have to be 100% novel that nobody has done it, okay? It does not have to be, right? It can be also industrial application regarded as useful, accomplish something in practical value to society, able to mass produce, meaning that it probably is not that novel, it's not something new, but in terms of application, there is a little bit of more user friendly. Okay, so those are also can be patented. Okay, so in I'm not going to tell you how to write a patent application, but in the patent application we have to write a few claims. Okay, so what do you want to claim? Is it in terms of new physical feature or new inventive step or a new industrial application? Okay, so we have to specify in the claim during our patent application. Okay, so we look at non-patentable, meaning that these are non-patentable. So scientific theories, mathematical methods, they are not patentable. Okay, even your ideas. Ideas are not patentable because during patent application, you have to submit all the experiment data. Okay, experimental data has to be submitted together with all the graphs, the bar charts, whatever, has to be submitted as evidence that it is that work is done by you. Okay, so you cannot just claim something in your head. Okay, this is my idea, I want to patent. No, you cannot do that. Okay, animal varieties cannot be patent, but there is something. There is another what we call as it's not here. Okay, new plant varieties. Okay, so it is one of the intellectual property, meaning that you can protect if you found a new plant, but it is under new plant variety. Okay, so animal, I'm not so sure, but if it is plant, then there is IP for that. Okay, so plant should fall under new plant varieties. Okay, method for doing business is not something that you can patent. Okay, diagnostic method as well is not something that you can patent. All right. Okay, here novelty is not something which can be proved or it only is absent. Okay, I don't really understand. All right. Okay, let's move. Okay, this is the process. Okay, I'm not going to talk about the process. So you can see it looks like writing a journal. Okay, abstract, background, summary, brief description of the drawings. If you have like scientific, remember about what we call as, I forgot the thing. The drawing that Baljic, I forgot the term. Abstract in the form of drawing. Okay, I forgot the term that I have used before. Detailed description of the invention, drawing again, and then the claims. Okay, so the most important is the claims. We cannot use the same claims that somebody else has patented before. So the search, what we call as the patent search, the literature search has to be done. Uh, uh, has to be done a lot. Okay, before you can write for the application of patent, you have to do a lot of literatures, okay, in terms of patent as well as papers, okay, because they will compare from the literature as well, from the patent as well, patent search, and as well as from the literature reviews, okay. Okay, the word is you have to do a comprehensive literature search. Okay, and there is, okay, yeah, independent claim. It's easy because it is not related to another claim, okay? But dependent claim, usually you are talking about probably affected by something else, okay? As I said, I'm not going to tell you how to write a patent, okay? But it is very important to understand what you can use, what IPs that you can use to protect your innovation. Okay, so copyright is more on artistic works, songs, musics, scripts. Okay, that is copyright. Right. What other? Okay, so this is about important for you to know about publication, because in future you will be publishing. So the ownership of your publication is the publisher. Because whenever that you agree to publish, you send your manuscript to the publishers, you have to acknowledge the copyright transfer. Okay, so it will be owned by the publisher. Okay, that's why whenever that you wish to copy certain pictures, okay, from the journal, you have to ask the approval from the publisher. Okay, not the author, is from the publisher. Okay, let's look at other copyright, other IP. So industrial design, okay. So this is also probably good for us if you are working with certain design during your research. Okay, the come out, the the final product, whatever come out from you have designed your your own prototype, so that has can be protected using what we call as industrial design. Okay, so these are example like shape, configuration, pattern. Okay, this also can be protected. Okay, trademark. Okay, trademark is quite easy to understand. It's about brand, logo, uh, name. Okay, right. Even the font. Okay. Okay, so this is can be that this can be trademarked. Okay. So what about trade secret? Trade secret is about formulation, recipe that you develop by your own. So it can be protected by trade secret. But you have to know how strong the trade secret can protect. Okay. Of course, patent is the best. Okay. Trade secret, I don't know how strong it is, but patent is the best. So formula for drinks, lubricants, okay, things that you do in the lab, especially recipes, formulations, marketing strategies also, I don't know, algorithms, okay, there's also other trade secrets, okay. Okay, these are characteristic of trade secret, unlimited duration, because for patent, okay, there is a time limit, and then it has to be maintained every year. Protection is theoretically worldwide. Okay, for patent, if you file for Malaysia, it covers only in Malaysia. So somebody infringe, meaning that use your innovation in Thailand or Indonesia, that you cannot sue them. Okay, but somebody infringe, it is the word is infringement. Your innovation inside Malaysia, that one you can do some litigation process. Okay, no procedural formality required, effective immediately. It's quite easy because you just fill up one form and then you can get the TS number. Okay, but I don't think it is, strong enough to cover or to protect your innovation. Right. If you tend to do trade secret, then you have to really protect. All right. Okay, this is just the process. Okay. This one, okay, you can always, because I've given you the slide in the Putra Blast, so you can just look at it. If in future you wish to apply for your IP protection, then you can use these steps, okay? Okay, any question before I move on to the last one? Any questions? Not yet interested in IP?
Prof,
Yes,
would you upload the slide after the class?
I have already.
Oh, have already. Oh,
Yeah,
okay, okay. I found it. Okay, thank you, Prof.
give me just a moment, yeah. Okay, all right. Okay. So just now is IP. So IP, of course, is towards the end after you have done, not to say towards the end. Sometimes after 1 year, you have come up with a process, then you can start protecting the innovation. You don't have to wait until you finish your research in 2 years or you finish writing your thesis, because if you find it and your supervisor find it important to protect, then you have to start protecting, because you have to do that as soon as possible, because once you publish, okay, let's say you want to publish, okay, and then 1 year after your publication, okay, it is called public disclosure. 1 year after your public disclosure, regardless journal, presentation, in conferences or exhibition, 1 year after that, if you have not protected, it is no longer eligible to be patented. Okay, so you have to be careful. You have to file the patent as soon as possible. You think that it is has some values, then you have to file for patent as soon as possible. Because if you disclose the innovation in the manner that I have said just now, conferences, exhibition, journal, and after 1 year from the disclosure, you can no longer patent. I'm not so sure about others, like trade secret. Trade secret probably you can, but patent is no longer eligible once you have disclosed more than 1 year. Okay, so you have to be careful on that, all right? Because usually we need to publish. As a student, you have to fulfill Master 1 paper and PhD 2 papers. Okay, so in order for you to do that, protect your innovation first, if you wish, before you publish. All right, so here I'm just sharing, okay? Just it's not really a theory, okay? I'm just sharing my experience, yeah? I'm just sharing my experience when I tried to commercialize my product. So there are two types of products that I have tried to commercialize. One is medical related. The other one is non-medical related, but it's chemistry, it's a polymer. Okay. So when you talk about commercialization, the definition of commercialization is different. Okay. So especially in science, commercialization in UPM, they define it is either you sell your own product, okay, meaning that you start selling, just like you're selling foods, you're selling other things. That is also commercialization, and the sale starts coming in, or you can choose to license or selling outright of your IP. So that is also commercialization. So for earth sciences, okay, some probably easy. I'm not saying that it's easy to uh, to sell these kind of things. Like if you develop creams, if you develop like uh, fertilizers, functional foods, you can sell it quite easy. Okay, well, probably some people do not agree. Okay, of course, you need to get the customers willingness to accept your products, but then uh, the hurdles, okay, the hurdles when you're working with medical related, and if you are working with high-end product, when I say high-end, it's like electronic devices, okay, and the application is on uh, like solar cell, battery. It's, I mean, it's difficult for you to go towards until the end product, okay, but you can sell your material if somebody finds it very good. You have developed a good, very good material for battery, for solar cell, for example. Then of course you can sell the IP. Okay, so that's what I'm telling you. For earth sciences, especially those like me who work for biosensors, okay, chemical sensors, and the polymer that I developed, I'm telling you, I'm going to tell about it, is for oil and gas companies. So it's a big market, but are you capable to commercialize it, commercialize it by yourself? So it's difficult. So one of the best way is to sell your IP or license your IP. Okay, all right. So in commercialization processes, actually, um, this is something that I learned, lesson learned, okay? Because at the beginning, no one talk about value creation, okay? So if you remember the video by Steve Jobs, okay? He talks about value creation, okay? He talks about customer, okay? Because what when we sell some things, we want the whatever product or processes or innovations to be valued by the customers. It's not just, okay, I'm going to sell you this, that's it. Okay. Uh, okay, you expect people will just accept the innovation that you have created. Okay. What you want to do is to create the value first. So how do you know that you are creating a value for someone? Okay. So these three processes, okay, value creation, refining the problem, engagement, this sometimes comes together, and sometimes the process, the engagements start, and then you go back to value. And once the value is there, you probably again refine the problem to meet the value, a better value, and then you probably go back to engagement and you found a few things. And since it is not really being valued, you go back to your problems, refining the problem again, refining the design again, because you want to create a value. Okay. So what I meant by value is like this, because I'm old. There are certain things that I cannot compromise, especially when you are old. You cannot compromise in terms of comfort. Okay. Um, like when you are old, you start having issues with your knees, with your back, with your legs. Okay. So when you have these issues, you start to uh, you start to buy a brand that really helps you. Like, for example, okay, uh, when I started to have issues with my knee, okay, with my legs, then I need to when I get to know sketches, I cannot change. I have to whenever that I have to buy a new one. Okay, I need to find sketches. Okay, so I have this personal bond with that brand. Okay, so that is the value of sketches that's given to me. Why? Because of the comfort. Because I can walk like 10,000 steps or many kilometers with that shoes. Okay, probably for young people it's not really attractive because the design is not attractive, it's not pretty, the look, the color is not pretty. But for me, like an old lady, what is meant for me, what is meaningful for me is the comfort. Okay, so I prefer to have the comfort. Okay, so that is the value created for me. It's not the same value created for you. You probably like other brands because it's more fancy. Sketches is not fancy. The colors are not fancy. The design is not fancy. But then for me, it is the comfort. So there are certain values that you have created for certain target markets. Okay, that's why the first thing that I discuss is to understand the problem. Because for you to understand the problem, you need to do engagement. Okay, so I'm just showing you the engagement that I have done. Okay, for example, I have tried to commercialize this two. Actually, this one not yet. Okay, one is rapid diagnostic kit, uh, rapid test kit for TB, tuberculosis, and this is a polymer. Okay, polymer designed to remove mercury. Okay, so I've talked about it just. Okay, so engagement is meeting the people. You cannot just read the literature. There's no way if you plan to commercialize only based on literature. It has to be with the people because those are your customers, and you are to create values for them. Okay, so this is one of the society in Sabah, because Sabah and Sarawak has the biggest numbers of TB cases. So if you know the situation, then you go to them, you talk to them, what do they need? Okay, do you like my product? Like, can if you have the alternative or the possibility using my product, will you use it? Okay, so they are very happy actually with the product because the current technique that has been used, even though the rural areas that they have to use a portable x-ray. Okay, otherwise those from rural areas has to come out, go to the hospital, give their samples to be diagnosed for TB. So it's quite troublesome for them. Okay, it's not like us here. We can just go to any clinics and probably being asked to submit our sputum samples. For them, it's quite difficult because the traveling there is not similar to us. It's not like us. The traveling is quite difficult for them, especially rural areas. So if we have at least a screening method, then probably it is workable for them before they are transferred to hospitals. Okay, so we have to understand their situation. Okay, so and then we also can ask how much money you're willing to pay for this test kit. Okay, so you can ask, you can talk to them, right? Okay, so that will be medical related. So I did engage for my polymer, okay, because my application, I'm targeting oil and gas. And of course, the market is very high. Okay, I knew that, for example, Petronas in Terengganu, they treated their, they called it, uh, all the words are okay, they treated their gas with still activated carbon, and that person shows me how much they spend, millions of ringgit Malaysia, just to treat the mercury. So if I like success in that, I'll be a millionaire. But of course, it is a difficult for you to gain confidence. Okay, so I work with their providers. Okay, because Petronas, they don't really do all their services by themselves, they outsource. Okay, so I talk to the companies that provide the services, to Petronas, to Shell, to okay. So I understand the situation. What are their needs? Okay, so once I understand with their needs, you can go back to the design, because sometimes whatever that you have right now does not meet their standard. Okay, so you need to go back, refine the problem, understand the market, then you try to recreate the value. Okay, without meeting them, without understanding their needs, there's no way that you can create a value. Okay, so another value that I would like to share with you once, because getting old is thought, it somehow have the positive value. You started to have, I started have to have issues with my skin. I can no longer wear synthetic clothes. Okay, we always love synthetic clothes like lycra or those ironless. Okay, those ironless uh, clothes. But unfortunately, when I got old, okay, I started to have skin irritation when I wear this kind of fabric, synthetic fabrics. So now I get engaged with Uniqlo or Muji because they have these technologies where they combine cotton, linens with certain synthetics. If you have to wear 100% cotton, you have to think about ironing. And it's going to be uh, time consuming just to iron to go to work. Okay, so I need um, a fabric that is probably no ironing or less ironing, but still it has the natural like cotton or linen that does not hurt my skin. Okay, so so now yeah, I mean, you don't mind spending a lot because you really want the comfort. Once you get old, comfort is very important for you. Okay, so you don't mind whether the color is not really nice or the design is not really nice, but then the comfort, and you don't have time to iron. Those are values. You know, you have to think about values in future, the user friendly, and it works for certain market sections. It doesn't work for everybody. As I said, the young one probably does not like sketches, but for me, the old people, like many of us wear sketches. Okay, so so when you talk about value creation, there are other things as well to answer your customer. Okay, you need to understand the stakeholder alignment. Okay, stakeholder means that for me, if I'm working with diagnostic, I have to like being endorsed by the KKM. Okay, whenever that, for example, and then like petroleum just now, then I have to get the endorsement of those companies, big companies, which is difficult, very difficult. Okay, so speed and precision is about when you start to discuss with these industries or whoever stakeholders who are interested with your innovation. You have to be reliable to them. Meaning that you have to answer, you have to give them that you are uh, good, okay, in coming back with whatever response that they need, okay, fulfilling the needs. Oh, there's a lot of things working with industries. And then, of course, they will ask you about the ROI, return of investment. This is the most difficult part for me because I mean, we are academic. We don't really calculate the values, how much you need to sell, how much that you will get in return. But at least we can do all this, meeting customers' needs, speed and precision, meaning that we are well prepared to redesign or whatever. And then stakeholder alignment, we know that it is really required in Malaysia. It is a need in Malaysia, for example. So these are the process that you can use, okay? All right, I think we are approaching the end. So engagement is very important, okay? So this is engagement for my e-notes just now. Okay, this is our e-notes, okay, that I have described in the slide just now. Okay, and then we introduce our e-notes to Sime Darby, okay, and we also work with MPOB. So you cannot just do literature, okay? If you're interested in certain uh, areas, formulation, drug discovery, again, you should be thinking about meeting the people behind. Okay, and once you, this is also important steps in commercialization is visibility. So you have to make yourself visible by, of course, doing conferences, presenting in conferences, exhibitions. Okay, okay, somebody wants to interview. Yeah, I agree. Okay, or you can also now use social media. Okay, social media for science innovation. Okay, so very important to be visible. If not, then people will don't have the confidence in you, right? So iterative steps is very important. Once, as I said, you engage and then you find that there's something wrong with your design, with your formulation, you iterate, you improve. Just like what we have in our Enos. So this is our first version of Enos. You can see that we need to have laptops together, and then the sampling also is quite difficult, but this one we come up with a new one that you can use portable device like iPad, tab, or phones to process the data, and is auto samplers. Okay, this one is manual sampling. Okay, so these are auto. So we improve our product or our design. And also when we first approach Petronas, um, they actually tested ours, but it was in the form of powder, and they said it doesn't work because the powder will get stuck in the filtration system. So we go back to the lab and design a proper form of the product. Okay, so you can see the size are bigger, the polymer are bigger, so where it will not get stuck in the filtration system or treatment system. So we have to quickly do it and try to send it back to Petronas, but unfortunately, the director is someone else, refused to test our product, and that is, of course, world is like that. Okay, right. Okay, so I think that's it. I have experienced a lot meeting people, trying to uh, pujuk them, those things are difficult. And there is, of course, regulatory affairs that you have to counter, okay, in Malaysia's, right? Yeah, I managed to sell, but there is but there. Okay, so always willing to open a new opportunity if there is, okay? And lesson learned, you have to learn about the value creation and market validation, market value. And you have to do engagement, or whether with professionals in that area or community. Okay, never uh, claim something that you have not done, have not tested. If it is not tested, just tell them I have not tested, so I don't know whether it works in that area. Okay, tell the truth. And if you start dealing with someone and they seems to be silent, move on. find a new partner and always have contingencies. Okay, that's how you work. All right, thank you so much. If there is any questions, I have another class at 6. Any questions before we end? No